All right, transformations of polynomial functions. We've got some parent functions here at the top. We have our quadratic parent function, y equals x squared, our cubic parent function, y equals x cubed, and our quartic parent function, y equals x to the fourth power. And notice that your quadratic and your quartic functions look very similar. It's just that our quartic function kind of flattens out a little bit more than our quadratic does. Now you've got this table in the middle of your note sheet, the function transformations. You've got your type of polynomial function, kind of its name, what the equation looks like, and then all of the places that you could find these transformations in each of them. They're all located in the exact same spot. So if you ever want to know what this looks like just based on variable representation, there you go right there. Now, what kind of transformations are we talking about? Well, we're talking about reflections. Those are just flips when our graph reflects across the x-axis or the y-axis. We are talking about dilations, and dilations are just stretches or compressions. And in this lesson, we're only dealing with vertical stretches or compressions. We're not using horizontal compressions or stretches at this point. And then, of course, we have translations, and translations are just shifts. We can have horizontal translations, we can have vertical translations. And over here are the ways that we would transform our polynomial expression, just in case you ever want to look back at this table and kind of identify where these different values are located. But I think it's easier to understand actual examples. So let's go ahead and do some of those. So given the function g of x equals 5 parentheses negative x to the third power minus 4, state the parent function and the equation, and then describe all of the transformations. All right, so I noticed that I have an exponent of 3. So this makes our parent function, f of x, equals x cubed. This is our cubic parent function. Now we need to determine what all of the transformations are. So I look at this and I see I'm multiplying by a 5 out in front of my parentheses. Inside the parentheses with x, I'm multiplying by a negative. And then I have this minus 4 here on the end. Okay, so I have 3 different transformations going on. So let's start with that 5. That 5 is outside the parentheses of my x. So it's not changing my x variables, it's changing my y variables, okay? And when I multiply the y variables by 5, it's making my graph taller. So this is a vertical stretch times 5. Vertical stretch times 5, or by a factor of 5. That says stretch. Sorry for the handwriting. Okay, then when we multiply our x value by a negative, anytime we multiply by a negative, that's going to be a reflection. So the question is, what am I reflecting across? So let me draw a little coordinate plane right here. And if I'm making my positive x values, if I multiply a positive x value by a negative, it reflects over here. And if I take a negative x value and multiply it by a negative, it turns into a positive. So what did those values just jump across or reflect across? They reflected across the y-axis, okay? So this is a vertical reflection, this is a reflection across the y-axis. You don't need to use the word vertical. Okay, puppies, don't bark. This is a vertical reflection across, it's not how you spell across, the y-axis. All right, and then we've got that minus 4 there at the end. The minus 4 is not in parentheses with my x variable, so it's changing my y variables. So anytime you are adding or subtracting, it's a shift or a translation. So because it's not changing x's, it's changing the y's. So this is a vertical translation. Some people say shift. Either word is appropriate, but you should know them both. This is a vertical translation or shift down 4 units. Okay, so anytime you're multiplying, it's either going to be a stretch or compression. Anytime you're multiplying by a negative, it's a reflection. And anytime you add or subtract, it's a translation. And like I said, that table on the front of your note sheet also shows all of those things. All right, so given the function g of x equals 1/2 times x minus 2 all to the 6th power plus 7, state the parent function and the equation. So we're doing the same thing again. And I recognize that my exponent is a 6, so my parent function is just f of x equals x to the 6th power. And we're not going to use a specific name for that. It's just a 6th degree polynomial. It's just a 6th degree polynomial function. Okay? Now, what kind of transformations are happening? So let's highlight again. I like highlighting. Keeps everything nice and neat. All right, so I know I'm multiplying by 1/2. So that's going to be a dilation. I see that we have a minus 2. So there's a shift. And I see that we have a plus 7. There's another shift. All right, so when I multiply by 1/2, is it inside the parentheses with x? No, it is not. So that means it's changing my y values. And if you multiply your y values by 1/2, you're making your y values smaller. That's why it's a vertical compression times 1/2. Vertical compression times 1/2. Now the minus 2 is in parentheses with my x variable. So because it's in parentheses with my x variable, it's changing my x's. And hopefully you remember from Algebra 1, anytime you mess with your x variable, you're going to use the opposite operation. So instead of saying x minus 2, well, we do say x minus 2, but it's shifting our graph to the right 2 units, okay? So this is a horizontal shift or translation, 2 units right. A horizontal shift or translation 2 units to the right. Now the plus 7, it is not in parentheses with our x variable, so it's changing our y values, right? It's changing our y values. So when we add 7 to the y values, it's a vertical translation up 7 units. Okay? All right, let's go in reverse. Let's look at these types of problems. It says, given the parent function f of x equals x to the 5th power, we want to write an equation of the transformed function that is reflected over the x-axis, that is vertically compressed by a factor of 1/4, and is, let's do blue, shifted 6 units up. So we have our parent function f of x equals x to the 5th power. If I want to reflect over the x-axis, let's look at that for a second. If I'm reflecting over the x-axis, that means I was a positive y and I become negative, or I was a negative y and I become positive, right? That's changing my y values. So a reflection just means I'm multiplying by a negative. So if I start my function, g of x equals, and I'm going to go ahead and put this x value in parentheses to the 5th power. And I'm just going to leave some space where I can fill in the blanks, okay? So to reflect across the x-axis, I'm multiplying my y values by a negative. So there's my negative out in front of the parentheses. Then I have a vertical compression by a factor of 1/4. Again, vertical is outside of the parentheses. It's not in parentheses with x, it's outside. So I am going to multiply by a 1/4 outside the parentheses. And then shifted 6 units up. If I'm shifting 6 units up, again, the up is implying that we have a vertical shift or a vertical translation. So we're going to add 6 on the outside of our parentheses. Now, I didn't really need this gap here, but I put it there just in case we did. So I scoot that over. And just so you know, because there is nothing in parentheses with our x variable, another appropriate way of writing this equation would be g of x equals a negative 1/4 x to the 5th plus 6. Okay? Because our order of operations, PEMDAS says, we always deal with our power first, with our exponent first, right? So this x to the 5th power, our x value has nothing in parentheses with it. So all of our transformations are vertical. We reflect our y values across the x-axis. We have a vertical compression by a 4th. We have a vertical shift up. So either way of writing this equation is completely appropriate, okay? And then our last example, it says, given the parent function f of x equals x to the 8th power, write the equation of the transformed function that is vertically stretched by a factor of 2. So let's underline, vertically stretched by a factor of 2, shifted 4 units left, and shifted 11 units up. All right, so we have our parent function f of x equals x to the 8th. So I'm going to start out with g of x again, and I am going to kind of leave some space here just to add in all of the missing pieces that I may or may not need. All right, so vertically stretched by a factor of 2. Vertical means y values. I'm not multiplying my x values, I'm multiplying my y values. So this 2 is going to go out in front, right? Multiplying by 2 out in front. And then I'm going to shift to the left 4 units. This shifted 4 units to the left. Remember, anytime you mess with x, you do the opposite operation. So instead of saying x minus 4, it turns into an x plus 4. So plus 4 goes inside the parentheses with x. And then I have this shifted 11 units up. So we're translating or shifting our graph up 11 units. Up means vertical, so we're not in parentheses with x, we're with our y values. So on the outside, we're saying plus 11. And those are just some examples of polynomial transformations.